Welcome back, everybody. We're going to work on section 1.4, which is all about solving quadratic equations. Remember, a quadratic equation is ax squared plus bx plus c, where they're all real numbers and a cannot be 0. One of the first methods that we can use to solve quadratic equations is the zero factor property. And basically what that means is when we get our factored form, because it's equal to 0, then both the factors equal to 0. So if I'm factoring this example 1, first thing I have to do is make sure it's equal to 0, and then I want it to make sure it's in standard form. So right now it's equal to 3. I'm going to subtract 3 from both sides. Standard form for that would be 6x squared plus 7x minus 3 is equal to 0. 6, 7, and 3 do not have any common factors to reduce by, so 6 times negative 3 is negative 18. The factors of negative 18 that add to positive 7 are negative 9 and positive 2. So I would do 6x squared. Oops, let's change colors there. It's brighter. 6x squared minus 9x plus 2x minus 3. 4 terms we're factoring by grouping. Greatest common factor on the left side is 3x, leaves us with 2x minus 3. The right side starts with adding. Remember, in factoring by grouping, you always have to pull out a greatest common factor. And in this case, our greatest common factor is 1. And we still have the 2x minus 3. We know we've done our factoring properly if we have 2x minus 3 in both parentheses. And then we pulled out 3x plus 1. Now remember, this is all equal to 0, because that's what we did here. Now that we have factored form equal to 0, we can say, well, 2x minus 3 is equal to 0, and 3x plus 1 is equal to 0. Solving for x, I would add 3, and then divide by 2. So x is equal to positive 3/2. Subtract 1, and then divide by 3. So x is equal to negative 1/3. So our solutions to that are 3/2 and negative 1/3. The square root property. If we're missing our b term, okay, and that's what I'm going to put here. Basically, you have to be missing the b term. Then we can either add in that 0b and do our factoring, or we can just do opposite operations. So we have the solution to x squared is equal to k. If we take the square root of each side, we would have positive k, positive square root of k, and negative square root of k, because every time we personally do a square root, there's 2 possible answers. We can abbreviate that to plus minus square root of k. So looking at these examples, if I start with example A here, I take the square root of both sides, and we have x is equal to plus or minus. 17 is a prime number, so I can't take the square root. I can't simplify it. It's just the square root of 17. Letter B, square root each side. We have x is equal to plus or minus. Let's see, square root of 25, we can change to the square root of 25 times the square root of negative 1. The square root of 25 is 5. The square root of negative 1 is I. So our solution is x is equal to plus or minus 5i. I would star letter C for note card purposes. And if I'm looking at solving that, remember this 4, the minus 4, is trapped inside the parentheses by the square. So in order to get to that 4, we have to get rid of the parentheses, and we can only do that by taking the square root on both sides. This all are opposite operations. So we're left with the x minus 4, now free of those parentheses. We have plus or minus because we personally took that square root. 12 is not a perfect square, but we can break that down. And we have a pair of 2's that can come out with this 3 left underneath. And so plus or minus 2 square root of 3 is over there. We finished getting x alone by adding 4 to both sides. Now we're actually going to add it in front of that plus minus, again, to avoid having it in the back and wondering, did we mean for that to go under the radical or not? And so x equals 4 plus or minus 2 square root of 3 would be our final answer. Completing the square. We have all of these steps to completing the square, and we'll just go ahead and start with an example. The only thing I do want to remind you is that we're taking half of b and then squaring it. That's part of completing the square. So the first thing I'm checking is, do I have a greatest common factor with x, 4, and 14? The answer to that is no. I would also want to check to see, well, can I factor this? Are there factors of negative 14 that add to 4? And the answer to that is also no. So I will start by moving the 14 over and creating a space to make this left side factorable. Whatever I add to one side, I have to add the exact same to the other in order to make it, with math rules, legal. So we take half of the b term, which is negative 2, and square it. Negative 2 squared is 4. So we add that 4 on both sides. We factor this left side, the factors of positive 4 that add to negative 4. And so hopefully maybe you can see that whatever this is the same here with an x. And that shortcut always works. And then we have 14 plus 4 is 18. Now we have the situation we just finished off with on the other page. I can't move this 2 away from the x unless I get rid of the square first to free it from the parentheses. So I'm going to take the square root on both sides. Those reduce out, so we have x minus 2 is equal to. We personally took the square root, so we would do plus or minus. Square root of 18. 18 is not a perfect square, but I can pull out a pair of 3's with a 2 left over. So 3 square root of 2. My last step then would be to add 2. And remember, we slide it in front of that plus minus so that our final answer should be x equals to 2 plus or minus 3 square root of 2. Let's try another one. So we would again say, okay, is there a greatest common factor? Nope. Can I find factors of negative 20 that'll add to positive 10? Nope. So I'm going to add 20 to the other side to create a space to make this left side factorable. And remember, whatever we add to one side, we have to add also to the other side. Take half of the b term, which is positive 5, and square it. That's 25. We factor that left side. We get x plus 5 squared. And 20 plus 25 is 45. Now we can work on getting x alone. First thing I have to do is get rid of that square. So I'll take the square root of both sides. Those are opposite operations and undo each other. We personally wrote a square root there, so plus minus. And then 45 is not a perfect square, but I know that's 9 times 5. 9 I can break down into 3 times 3. So I can pull out a 3, and 5 stays home under the radical. Again, our last step to get x alone is to move this 5. So I'm going to subtract 5 and put it right in front of that plus minus. So we have x is equal to negative 5 plus or minus 3 square root of 5. Example 4. Now in the steps it says check to make sure that a is 1. Well, up here in example 3, a was 1, is 1x squared. But in example 4, it's not, it's 9. I have to divide every single thing by 9. Remember, it's all or nothing on these, otherwise you change the problem. So everything gets divided by 9. And I'm going to write this up here. That means we have 1x squared minus 12 ninths reduces to 4 thirds x plus 1 equals 0. Now we can work on completing the square. So we're going to take this 1 and subtract it to the other side to create that blank space. We are going to take half of the b term. So 4 thirds divided by 2. Negative 4 thirds divided by 2 is the same as 4 thirds times a half. Just remember, we don't divide fractions, we multiply by the reciprocal. When we do that, that makes this negative 2 thirds that we're squaring. 2 thirds squared is 4 ninths. If I factor this side, now this is where that shortcut comes in handy. The factors of positive 4 ninths that add to negative 4 thirds. That would be a little tricky to do in our heads. So knowing that we take whatever we have here and put the x with it, and then negative 1 plus 4 ninths, that's negative 9 ninths plus 4 ninths, which is negative 5 ninths. Now we can get the square taken care of by square rooting. That gives us x minus 2 thirds is equal to plus or minus. So we take out the negative with an I. And then we say, well, that's the square root of 5 over the square root of 9. I can't take a square root of 5, but the square root of 9 is 3. And then our last step is to add 2 thirds over. So x equals 2 thirds plus or minus I square root of 5 over 3. And that would be our final answer. Let's try another one. No greatest common factor, and I cannot complete the square unless a is 1. A is 4, so we're dividing every single thing by 4. That gives us x squared. I'm going to reduce 6/4 to 3/2. 5/4 I can't do anything with, and 0 divided by 4 is 0. From here, I can subtract 5/4 to the other side, creating our blank space for us to get a perfect square. From here, we take our b term, which is 3/2, and divide it by 2, then square it. Well, again, 3/2 times 1/2, because we don't divide fractions, we multiply by the reciprocal, is 3/4. And 3/4 squared is 9/16. So this left side factored is x plus 3/4 squared. We'd have to multiply by 4 here to get common denominator, so that's negative 20/16 plus 9/16, which is negative 11/16. Take care of the square by doing the square root. That gives us x plus 3/4 is equal to plus or minus. Again, pulling out that negative with an I leaves us with the square root of 11 over the square root of 16. Can't do anything with the square root of 11, so that stays, and the square root of 16 is 4. Our last step is moving this 3/4 to the other side by subtracting. So we have x is equal to negative 3/4 plus or minus I square root 11 over 4. Quadratic formula. If something is not factorable, you can always use completing the square, or you can always use quadratic formula. Always happens to be something that we can use to solve no matter what. A lot of people prefer quadratic formula over completing the square, but it's just kind of how you personally feel. One thing to remember here is that we always have to equal 0 before we get started. So if I'm looking at this example, it's not equal to 0, so I need to start with adding 2 to both sides, making sure that my quadratic is in standard form. Now that it's in standard form and equal to 0, remember there's a 1 there, so that's A. This is B, this is C. Never use the variables when you're plugging this in. Excuse me. Never use the variables. Only use the coefficients or the constant. Okay? So we have our A, B, and C. Plugging this in, we have x is equal to negative, B is negative 4, plus or minus the square root of negative 4 squared minus 4 times 1 times 2, all over 2 times 1. If I simplify the top, a negative 4 is really a positive 4. Negative 4 squared is 16, minus 4 times 1 times 2 is 8. So this cleans up to 4 plus or minus the square root of 8 over 2. We're going to go ahead and clean up that square root of 8. It's not a perfect square, but we can reduce this. I have a pair of 2's that can come out. So that's 4 plus or minus 2 square root of 2 over 2. And then again, as with any fraction, we always make sure that we check for reducing by common factors. Remember, you cannot count the square root of 2 as a common factor because the square root is not the same type of number. This 4 reduces by 2 to 1. 2 divided by 2 is 1. 2 divided by 2 is 1. So we're left with 2 plus or minus the square root of 2. You can put the 1 in front of here if you want. You can put it over 1 if you want. but you don't have to. They both mean the same thing. All right. Same thing here. We have to start with making sure it's equal to 0. So I'm going to subtract the x and add the 4 over here to the left. So that's 2x squared minus x plus 4 is equal to, all of that adds to 0. Now that it's equal to 0, I have a, b, and c. So x is equal to negative, b is negative 1, plus or minus the square root of negative 1 squared minus 4 times 2 times 4, all over 2 times 2. Minus negative 1 becomes positive 1. 1 squared is 1. 4 times 2 is 8 times 4 is 32. So underneath the radical, I have 1 minus 32, which is negative 31, over 4. Really nothing I can do to simplify the 31, but we do have to make sure we take out that negative. So our final answer would be x equals 1 plus or minus I square root of 31 over 4. I have no other like terms, so that's it. Looking at this example, I see the sum of cubes formula. And we had said way back when we were factoring this that the second part of the sum of cubes formula is never factorable. However, everything is solvable. We have the tools, we can solve any problem. So let's start with putting this in the cubes formula. So we're taking the third root of each. Third root of x cubed is x. This is an addition. Cube root of 8 is 2. X squared is x squared minus 2 times x is 2x plus 2 squared, which is 4. And all of that is equal to 0. So we can now separate this into two separate parts. X plus 2 is equal to 0, and x squared minus 2x plus 4 is equal to 0. Over on the left side, solving for x is really super easy. We're just subtracting 2 to the other side, and that solution is x is equal to negative 2. On the right side, however, we know this is not factorable, so we either have to complete the square or use quadratic formula. If I'm using quadratic formula, I have a is 1, b is negative 2, and c is 4. So x is equal to negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 4, all over 2 times 1. Negative 2 is positive 2. Negative 2 squared is 4. 4 times 1 times 4 is 16. So 4 minus 16 is the square root of negative 12 over 2 times 1 is 2. We have to clean up that square root and then see if there's anything we can do to reduce. Now we know that with the negative we have to pull out an I. And so 12 is not a perfect square, but we can simplify this. I have a pair of 2's that can come out. So if I pull that out, I have x is equal to 2 plus or minus. We pull out this pair of 2's. We pull out the negative, square root of negative 1 with I. And then the 3 is stuck underneath the radical still. And then if I'm checking common factors, all of these 2's have a common factor of 2. And so we have x is equal to 1 plus or minus I squared of 3. That, along with our x equals negative 2, is our full solution. We're going to take care of this another time and go straight to the discriminant. So the discriminant is the square root of b squared minus 4ac portion of the quadratic formula. More specifically, it's just what is b squared minus 4ac. This tells us how many and what kind of solution we're supposed to get. So if, when we do b squared minus 4ac, we get a positive perfect square, so like the square root of 4, then we have two solutions that are both real and rational. If we have something, when I do b squared minus 4ac, that is positive but not a perfect square, for example, maybe it's the square root of 11, we still have two solutions, but they are irrational. And a lot of times pi is still going to be in your answer. If we do b squared minus 4ac and we get 0, square root of 0, that means there's only one solution, which is called a double solution. And it can be real and rational. Oops. If you get negative, so b squared minus 4ac is negative, like the square root of negative 12. You do get two solutions, but in this case, they will be imaginary and complex because you will end up with I coming out. Remember, I is part of our complex number. So for this last example, it's asking us only to find out how many of which type of solutions we will have. We are not solving. So if I'm looking at letter A, first we have to make sure, is it equal to 0? Yes. So we have A is 5, B is 2, and C is negative 4. Remember, we're only doing b squared minus 4ac. So 2 squared minus 4 times 5 times negative 4 gives us positive 84. So this will be two real irrational solutions because the square root of 84 is not a perfect square. So we're on this second part right there. For letter B, this is not equal to 0. So my first step is to add 25 to the other side. So we have x squared minus 10x plus 25 is equal to 0. That means that our A is 1, our B is negative 10, and our C is 25. If I plug that into b squared minus 4ac, we'd have negative 10 squared minus 4 times 1 times 25. Well, 10 squared is 100. 4 times 1 times 25 is 100. 100 minus 100 is 0. So this is one real, rational, double solution. For example C, all of these, it's equal to 0. It's in standard form. We have A, B, and C. B is -1, so -1 squared minus 4 times 2 times 1 gives us -7. So that means there are going to be two imaginary complex solutions. That's it for this set of notes. Thanks so much for joining me. I hope you have a great night.